All right, so a little bit more on some more graphs for quantitative data. So we saw a lot of them there where we had the histogram, we had the frequency polygon, and we had the ogive. And they weren't all that much different from each other. So the most of them just depended on having those frequency distributions that we made. So these are going to be a little bit different. So graphical summaries for small data sets is what we're going to be looking at. So the other ones were like a big data set where we had a lot of points, but if we have smaller data sets, these are some other displays we can use. So it's sometimes more useful when we have small data, use graphical summaries that are more detailed than histograms. In this section, we're going to look at some commonly used ones like a dot plot, stem and leaf plot. So I'm going to start with that stem and leaf plot. So the stem and leaf plot is going to feel very much like something you would have done in middle school. So stem and leaf plot are a simple way to display a small data set. So in the stem and leaf plot, the rightmost digit or digits, however you have it set up, is going to be your leaf, and the remaining digits are your stem. So for us, we're usually going to leave one digit off. So if we had 14.8, we'd split it here. And that 14 would be your stem, and that 8 would be what we consider the leaf. If we had 2,739, then we'd break off that 39. So that being said, I have seen them done differently, like they might split them here sometimes, but as far as we're concerned, we're always going to split with the last digit. It's going to be that leaf. So we're leaving the last digit as a leaf. So this following table represents the U.S. Census Bureau project for projections for the percentages of populations age 65. I think it's probably 65 and over. We will construct a stem and leaf plot. So what we do is for a stem and leaf plot, we're going to make a bar like this. In case we make mistakes, we'll get this checked in a minute. So you can do it like this. And what you're going to have is one side is going to be your leaf, or sorry, your stem. And then this side will be your leaf or leaves. So we're taking all this data and we're just splitting it so that last number is left off. Okay. So let's do this for all of them very quickly. Hopefully we don't miss something here. It's a lot of data to look at really quick. But what's going to end up being the stem is those first two numbers. So we have some 13s, there's a 15, a 14, another 13, a 10, a 9, a 14, maybe I said 14, 12, 16, 13, 14. We're going to look for that smallest stem first, which I believe was this number 8 over here. So we'll start in an 8, then we're going to have a stem for a 9, a stem for 10, 11, 12, 13, 14, 15, and all these stems may not have leaves. We're just hoping they are. And I think the biggest I had was the 16 over here. So I think that's where we'll stop it. Okay, so as far as the leaf goes, look for anything that starts with that 8. And I think we just had the one data point in there. Hopefully I don't miss it, but it looks like it was just the one. So this 1 here becomes the leaf. If we look at number 9, we got 8 out of the way. So anything with a 9 at the beginning, I think there was only one of these as well. Yeah, right here. And we had a 0 was the remaining decimal, the last one, the last number in the whole thing. So it's that 0. So we'll get rid of that. And then if you look at 10s, so here is 10. So we got a 10.2, a 10.7. See if there was another one here I missed. A 10.5. So we're going to write down those digits. So we have a 7, a 2, and a 5. And we don't usually put commas between them. And later what you're going to see is that we're actually going to order these leaves. We like to have them in descending order. We're just worried about showing you how this works. So I'll just demonstrate with one more. So if you do 11, maybe 2 more depending on what we need. There's an 11 Here's an 11. So both of them have a 5. So we rate that 5 both times. So this is a little different than some things you've been told where you don't duplicate numbers. When you have stem and leaf plot and dot plots, both of them, you duplicate numbers that you have. Do we have another 11? I might. We're going to stop there. I think you got to get the general idea. So you just keep going through and you keep looking for all those stems. So let's look at the whole plot over here. And we're going to make one again. So if you did look at that data, oh, I missed a number in the tens, it looks like. No, I hit them all. So like I said, so the 8, we had an 8.1. So the first part is the stem, this is the leaf. We had a 9.0 stem leaf. We had a 10.7, a 10.2, and a 10.5. So that last number became all those leaves. You could have gone through and done this for all of your numbers. And this is what the display would have looked like. So as you see, we went up to 17. I thought we stopped at 16. Apparently there were no 16s, so we didn't write the 16. So like I said, or no, we had one. We had one 16 at 0. So sometimes you might have a gap in here, like maybe there were no 15s, then you would write nothing in there. So right here we have a 16.0, we have a 17.8. So we went further than I thought. And then the other part I said is we don't like these numbers just in random order. We like to put them in order from smallest to largest. So we would relist this. So we'd go with the zeros first, then the 2s, then the 3, then the 4s, which we had 4 of, and then the 2 6s, the 7, and the 2 8s. So you can always make a vertical list of all your stems. You're going to do it in increasing order. So you start with your smallest stem. And then you have your largest stem. And then you make sure that you get every number that's in between them. So we're not skipping anything. Each value in the data, for each data set, you write the leaf next to its stem. And then we would like to arrange for each stem, rearrange those leaves so they're in increasing order. So I think I actually said descending order and I'm ascending. So we like to have them in ascending order. I think I said that backwards last time. I just came off doing polynomials and everything's descending order there. My brain's a little stuck. Just a second. Sometimes it does something weird in my slides. There. We also can have back-to-back stem and leaf plots. So this is when we have two data sets that should have about the same stems, and we're doing it to compare each other. So two data sets have very similar values similar enough so that the same data can be used, same stems can be used. Their shapes can be compared with a back-to-back stem and leaf plot. Consider the following course averages for an English class and a history class. The classes can be compared with a back-to-back stem and leaf plot. So what you kind of get out of this is one of those things we were talking about earlier with shapes of distributions of data. So we see that both of these, they're a little skewed. They're skewed towards smaller values, so this would actually be skewed left. Because if we went and we turned this up like this, we'd see it look more like that. Both of them are skewed left, so that's one of the things you get out of this. The other thing is we can kind of see averaging of grades. So it looks like for this English class, a lot more people are getting C's compared to your history class where people are more likely to get B's. Yeah, I know that because these are all 70s, these are C's, these are all 80s, these are B's. And just remember when you're reading these, this is telling you what the number should be, so you know the number is 45. This one here, because you're doing it backwards, that is 100, with this just a straight 100. You got to be a little careful with reading these that you remember where the stem is. The stem is always going to be written first. So just as a quick example, we have this data on the heights of men and women. And I wouldn't gather a lot of information out of this one, because it was a little random. It wasn't a good data set that I had here. But if I wanted to make a back-to-back stem and leaf plot, I put my stems here. So because we have men here, we're going to say we're going to put men here, and then we're going to put women here. So in this case, you have to compare both data sets. I'll look for your smallest and largest values. I'll be honest, I think these are switched because these look like men heights. I think this is men and this is women. So I'll order it to match our data so it's a little less confusing. So we see the smallest for women we get is 40. So these are in order. The biggest is 70. For men, the smallest is 50, but the biggest is 80. So I want to make sure I start with a 4, because we're looking at that first number. That is going to be my stem. You don't usually write stem here, but we're going to. 4, 5, 6, 7, and then I want to make sure I have that 8 because that's where I maxed out. So we'll do women first. Like I said, put in order so this one's a little quicker. So if we just do women, we have one woman who is 48 inches. So put the 4 here and the 8 there. Then we have a woman who is 53 inches, 5 there. So we put the leaf of a 3 here, 58. So we put the 8 over here. So I'm going to put these ones in order, actually. So we had 3 and 8. So make sure you put in order from smallest to largest. When we look at the 60s, we got a leaf of 0, 1, 5, 4, 4, 5, 5, 5, 6, 7, 7, 9. So I'm going to write these backwards on here. So we had a 9, we had a 7 and a 7, and then we had a 6, and then we had a bunch of 5s. How many did I have? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 5. So we get a 4 here, a 4 here, a 1, and a 0. So that's a really big, there's a lot of leaves on that stem. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, make sure I didn't miss something there. And then for the 70s, we have a 0 and a 1. So we don't have any women who are 80 inches. All right, and the other side, we're going to put the men. So I don't have any men who are 40, so we leave that blank. But I do have some that are 50. So my leaf is going to be that 7. So we have 57. Then for the 60s, that's going to be another big one. So we have a 60, so we get 0, a 62, so we get to 2, a 64, so we get the 4, a 65, a 66, a 66, a 67, a 68, and a 69. Barely fit it in there. The 70s, we have a 70, a 70, a 72, a 73, and a 78. And then my 80s, I only have 1. Once again, if you are analyzing this, overall, you can see that women tend to be a little shorter than men, maybe not, I'd say by a fair amount, because most of your men are up here. So you got quite a few in their 70s or 70 inches and a lot in the 60 inches. So this is mostly 5 foot something. And this is mostly going to be, some of it's 5 foot and some of it's 6 feet. This is mostly people that are 5 foot something.